So we are discussing FLT3 paper. This is question number 26. I'll show you the topics. So these are the topics for the test. We will be discussing electrostatics part of physics. So let us begin from question number 26. So question number 26, it says capacitance of sphere of radius r and that of cylindrical capacitor of length capital R are same. So we all know spherical capacitance is how much? 4 pi epsilon naught R. And what is cylindrical capacitance given as? So cylindrical capacitance is given as 2 pi epsilon naught. L is length of the cylinder. And we have log of R2 by R1. So R2 is the outer radius, R1 is the inner radius. See here, R2 is this, R1 is this. So now it says they're both equal. So we'll just equate them, and we see that another thing, length is also given here as R, of length R. Okay. So it says, so since L is equal to capital R, so we'll just substitute L over here as R. So this goes with this 2 times, and ln of R2 by R1. So R2 is outer, R1 is inner. And we are supposed to calculate ratio of outer to inner radius is, this comes out to be half. Therefore, R2 by R1 is equal to e raised to, which answer is this. Moving on to the next question. So in this question, it is given that we are given with two capacitors of capacitance 1 and 2 microfarads. It is charged to 1 volt, let's say 1 microfarad. So here Q1, the charge that appears here will be Q is equal to C times V, CV. So this comes out to be 1 microcoulombs, and this comes out to be, here the charge is going to be Q2. This is 2 microfarad. It is 2 volt. So Q2 here is CV, which is 2 microcoulombs. Okay. So now it says that their terminals are connected. That means 1 microfarad and 2 microfarad both are connected. So if both are connected, that means now they're going to share a common potential difference V. Let's say this is V1. So let's say we have a common potential difference V here. Now, okay. So, so now what we can say is, let's say this is charge Q1 dash and this is charge Q2 dash, and C1 V equals to C2 V. I'm sorry. Q1 dash is equal to C1 V and Q2 dash is equal to C2 V. Therefore, Q1 dash by C1 equals to Q2 dash by C2. It implies Q1 by Q2 dash, that is after joining, is going to be C1 by C2, which happens to be 1:2. Now, we all know net charge is going to remain same, that is Q1 plus Q2 is going to be Q1 dash plus Q2 dash, and we know this is in the ratio 1:2. And before this was 3 coulombs, Q1 plus Q2 is 3 coulombs, 3 microcoulombs. And if we just solve this expression, from here we get Q2 dash as 2 times of Q1. Q2 dash is equal. So if we just put it over here, Q2 dash is 2 times Q1 dash. So here we get 3 Q1 dash equals to 3 microcoulombs. Q1 dash is equal to 1 microcoulombs. And Q2 dash is equal to therefore 2 microcoulombs. Just a second. So I'm sorry, I just made a mistake. This is going to be C2 into V2. This is going to be 4 microcoulombs. Instead of 2, it's going to be 4. Okay. So now if you just see, so Q1 plus Q2 is instead of 3, it will be 5. 5 microcoulombs. So just make some changes over here. 5. So from here what we get is Q1 dash is, from here we get Q1 dash as 5 by 3 microcoulombs and Q2 dash as uh, twice of this, that is 10 by 3 microcoulombs. So we have to take care of this as well as this. Now, now energy stored before. What was the energy stored before? That was half CV square, C1 V1 square, half C2 V2 square. Okay, we can also calculate here potential difference V. So if I just say V is equal to Q1 dash by C1. So Q1 dash is how much? 5 by 3, and C1 is how much? C1 here is 1 microfarad. So this goes to be 5 by 3 volts. Now when you calculate energy, when we calculate energy over here, energy comes out to be energy before, because see in the question it is asked the potential energy of the system. So potential energy before was half C1 V1 square plus half C2 V2 square. Okay. So energy initial was how much? Was half C1 V1 square plus half C2 V2 square. When you put the values, you get C1 V1 square and half. So we need to put the values. So this happens to be the energy. You can see I have just put all these values. Put all these values over here. Half C1 V1 square. So you get 4.5 joules. Now energy, final energy is how much? Half of C1 plus C2, because potential difference is same. We can just write it like this: C1 V square plus C2 V square. So this expression would look something like this: half into 1 plus 2 into V. V is how much? Potential difference is 5 by 3 whole square. So this comes out to be 9 is 25 by 6 microjoules. So final minus initial, we need to calculate potential energy, energy of the system. So we just need to see how much is the change in potential energy. So this is final minus initial. Let's do that. Final minus initial is how much? So this is 9 by 2. Okay, we just write it as it is. So this comes out to be 4.166 minus 4.5 microjoules, so minus 4.5 happens to be minus 0.333 microjoules, which also happens to be minus 3.33 into 10 raised to minus 6, sorry, minus 7. Because here it's going to minus 6, so you can just write it like minus 7. If we put a one decimal over here, it will become this side will increase. So because it is having a negative sign, so we can say energy will decrease, probably decreases by this much amount. So question number 28, two electrons, they're separated by some distance d. Okay, that's some distance, let's say 1 centimeter apart, and they experience some repulsive force. So let's say this is 1 centimeter apart. Now when you put a when you put a metallic plate between them, what is going to happen? So metallic plate will do what? It will not allow this electric field to go through itself. Correct. So what will happen? Here what we see is, here if it's a negative charge, so here some positive charge will appear. Same will happen here, some positive charge will appear. Okay. And probably this will connect to this, and this will connect to this, and now this won't be able to repel it. So I think it should be zero force, because we should always know that electric field cannot pass through a metallic thing. Electric field will balance itself in such a way that net electric field here is always zero. So this electric field will not be able to penetrate this metallic surface. So we always say zero force. It may need not be like this arrangement. It could be something else also, but point is electric field will never be able to penetrate the metallic surface, because of which we can always say the force between electrons will become zero. So let's see the next question. So now three capacitors are connected in series. So one is 2 microfarad, another is 5 microfarad, and another is 10 microfarad, connected to a 2000 volts. So let's this positive, this is negative. It's 2000 volts. Now what we know is here charges are going to be same, Q, Q, and Q, and obviously minus Q, and minus Q. So what we can say here is Q is equal to CV. Q is equal to CV. So V is equal to, or rather Q is equal to CV. Yeah. So here let's say potential difference is V1. Here let's say it's V2. Here it's, let's say it's V3. So C1 V1 and C2 V2, C3 V3, like this we can say. So V1. So here V1 is going to be Q by C1, which is going to be Q by 2 microfarad. V2 is going to be Q by C2, which is going to be Q by 5, and V3 is going to be Q by Q by C3, which is going to be Q by 10. Okay. So itna volts. So we know V1 plus V2 plus V3 is going to be 2000 volts. V1 is Q by 2, V2 is Q by 5, V3 is Q by 10, 2000 volts. Now, when you solve this whole thing, you get, you can just take 10 as LCM over here, and 5Q, 2Q plus Q. So when you solve this, you get 20,000 divided by 8 as 2500 coulombs or microcoulombs. Yeah, microcoulombs. Now, we know this in microcoulombs, this is in microfarads. So micro will cancel out, and we get here V1 as, Q by C1. So Q is how much? Q is 2500. C1 is 2. So this comes out to 1250 volts. Similarly, V2 2500 upon 5. This is 500 volts. And V3 Q by C3, Q by C3, this is Q by this 10. This happens to be, this is 250 volts. So this is going to be, this is going to be A. A will be the answer for this. So in this question, we all know, if we read this question, we can see very carefully that dipole P is centered at the origin. Means what? If this is our origin, dipole is placed here and it's placed here. Dipole is placed somewhat like this. This is minus Q. This is plus Q. And this is going to be QE here like this. This is going to be QE over here like this. And F net is going to be, let's say this is F1, this is F2, F1 minus F2. So so if we just see F1, F1 is Q into E is how much? E, if let's say this this length is of dipole is D, this is also D. Total length is 2D of the dipole. So this is going to be plus D and this is going to be minus D. So we'll put the values of X over here for F1. It is going to be Q into A D the whole square plus B into D plus C. इसी तरह we find out F2. It will be Q into A minus D whole square, B minus D plus C. Let's do F1 minus F2. When we do it, we find that AD square plus BD plus C minus of UAD square minus BD plus C. So we see this and this will cancel. This and this will cancel. F1 minus F2, which happens to be F, it comes out to be F into 2BD. So Q into 2D is how much? P. P times B. Therefore, B is F by P. So for this, correct option will be C. So for solving this question, 512 is nothing but can be written as 8 cube. Okay. And now we know that energy stored is half CV square, which can also be written as Q square by 2. So this is another form of energy stored. So energy stored in one drop. So let's say we have a one drop of radius small r. So what, and it has some charge Q on it. So energy stored on this drop will be Q square upon 2. What is the capacitance of the spherical drop? Capacitance of a spherical drop is 4 pi epsilon naught small r. So likewise, we have 512 droplets. So total initial will be how much? 512 q square by 2 into 4 pi epsilon naught r. Now, when we merge these small drops into such 512 drops into a one big droplet, let's see what is the radius of this big drop. So when we do volume conservation, we find 4 by 3 pi r cube is equal to 4 by 3 pi r cube. So this is 512. Okay, so once you 4 by 3 pi, 4 by 3 pi goes, so we are left with r is equal to 8 times small r. So now final energy is going to be q square by 2 into 4 pi epsilon naught bada r. And r we can, this can also be written as, okay, so here q, and I didn't mention it here. So now because all these drops were having a charge of q and they merged to form a bigger drop. Okay, so total charge that will now appear over here will be 512 times q. So we have to take square of this now. So finally this would look something like this. 512 q whole square upon 2 into 4 pi epsilon naught, and instead of r we'll write 8 into small r. Now when I take ratio of final to initial, so when I take ratio of final to initial, what I get is, or we are supposed to calculate uh, before and after, yeah. So initial to final, when you just take a ratio of initial to final, so initially it was 512 q square 4 pi epsilon naught r upon q square. So finally, when this whole thing goes with this whole thing, and this goes with probably this q square goes with it. You solve everything, you get here 1 by 6. You can solve it and see it yourself, you get 1 by 64. So our answer will be this. So only we have to just, after once we calculate initial and final values, we have to take ratio of these two numbers, probably this number or this value, and we have to take ratio of this value. So if you take ratio of these two values, you get 1 by 64. So now in this question, what we're given is two spheres of radii R1 and R2. they were having some charges like let's say Q1 and Q2, correct? So so capacitance of these two charges will be 4 pi epsilon naught R1, 4 pi epsilon naught R2. This will be the capacitance of these two spheres, and when they're connected by a wire, correct? So what is going to happen? Potential is going to remain same. When we connect to capacitors, potential becomes same. So these two spheres, they're going to come to same potential. So we know Q is equal to CV, potential is going to be same. So V is equal to Q by C. So we can simply say here Q1 upon 4 pi epsilon naught R1 equals to Q2 upon 4 pi epsilon naught R. You can see this is also the potential of a sphere. So potential of the spheres are going to remain same. So 4 pi epsilon naught cancels, 4 pi epsilon naught cancels. So here we get Q1 by Q2 is equal to R1 by R2. So Q1 by Q2 is equal to R1 by R2. This is our answer. So for question number 33, so let us see. Here what we are given is, here the velocity is V naught, and we're supposed to calculate this angle theta over here. So what we can see from here is length of this plate is L. So if this is an electron, and we know this is a positive plate, this is going to be negative plate, electric field is like this. So force on this electron is like this. So what is the acceleration along y axis, y direction is QE by acceleration along x is 0. So velocity along x remains same. Therefore, time is equal to L by Vx. Okay. Okay. So T is equal to L by Vx. So now this displacement along y will be how much? Displacement along y. This is how much? Half of a ay into t square, and x is L. Displacement along x-axis is L, and we all know tan theta is how much? Tan theta here will be displacement along y upon displacement along x. So displacement along y is half q e. Q can be also written as e as given over here. L square upon vx the whole square upon L. So which happens to be half e L upon vx square. This is going to be tan theta. So theta is tan inverse of this whole value. So tan inverse of EEL upon t square, EEL upon, just a second. So here y component of initial velocity along y is not present. On AY into T. T was how much? T was L by Vx. So I think here a half term should also come. Okay, so actually, if you see here, our half term is coming extra. So what actually we have to think this question little differently. So let me first tell you the concept. Actually, if you just see in case of a projectile, correct? Let's say we are talking about a projectile. So if a projectile is thrown from this point to this point like this. So if we simply take y upon x, So it gives us this angle. It gives us this angle, correct? This angle. But if you see about velocity, what I mean, if you just see the direction of this, direction will be always given by velocity. So if you can see, well, the direction of velocity and direction of y upon x, they are quite different. Okay, so I mean, let's say this is some angle phi. So we just need to calculate this angle phi. So this angle can be calculated by taking the components of the velocity. So since here I have taken components of displacement, I'm getting a half term over extra. Okay, so if I simply take components of velocity, I think we'll get our answer. So let's take components of velocity and see what do we get. So I'll just delete all this. I hope you got the concept. So if I take components of velocity, velocity will be, so v along x is always v naught because it's not changing, and v along y is ay into t. T we have already calculated, L upon v x, which is v naught mostly. Okay, so ay was qe by m, qe by m into L by v naught. Therefore tan theta will be Vy by Vx. So Vy is QEL upon MV naught square. So you can see the dimensions are same and we get tan theta is this. So I think this would be the option. Another way of doing this kind of question is you can simply see the dimensional analysis. So whatever will have a dimension, whatever quantity will be dimensionless, that will be actually your answer. This is a another way of doing it in case you're not getting by solving and all. So you can simply see the dimensions of the quantities given. Whichever comes out to be dimensionless, that is going to be your answer. Just for example, here if you see mv naught square, so this is dimensions of energy, correct? So if you see here, this is E into EL. So if you just see here, E into E is coulombs. This is newtons per coulomb into L. So this is newtons. No, this is dimensions of work upon mv square. This is also dimensions of energy. Now again, this is dimension of energy. This is not the dimension of energy, mv square. Okay, so but here what we can have is a confusion in B and C. So for that, I think we need to solve. Otherwise, if you see, this will not be there, this will not be there. There would be. So I mean, you can just eliminate at least two options. You can eliminate. Okay. So let us go on the next question. Question number 34. So in this question, we can assume a cylinder which is uniformly charged. Let's say charge density of the cylinder is rho. So means this is volume, some volume. So volume of the cylinder is uniformly charged. Now what we are going to do? We are going to, let's say, takes a small radius r from here, and at this point we need just to calculate E at this point. So if let's say this is charged with positively charged, so what will be the direction of E? It is going to be like this. Yeah, whatever that is, we'll just see that. So we know, so E at a distance r from the axis. So this is axis. So at a distance r from the axis, E is going to be, we can say, E dot ds by Gauss law, Q by epsilon naught implies E. We need to calculate ds at this point ds is going to be, ds is 4, I'm sorry, 2 pi rl, and now q is going to be sigma into pi r square l. Q is going to be sigma into pi r square l upon epsilon naught. So when you solve all this expression, you see 2 pi, 2 is not going to get cancelled, 2 is remaining going to be over here, and r goes with this, l goes with this. So we are left with E is equal to sigma r by. So we see E is directly proportional to r. So this is going to be the answer for this. So in this question, we can see, let's say capacitor, dielectric constant for this is K1 and for this is K2. So when we consider this into a capacitor, it will be epsilon naught A by 2 into D, which happens to be C by 2. And for this, so this is C1, this is C2, and this is C3. This is C1. C2 is going to be epsilon naught A by 2. This is D by 3. So this is going to be 3 epsilon naught A by 2D. And similarly, we can get C3, which is going to be epsilon naught A by 2D by 3. A by 2 also here. We've already taken A by 2 and D by 3. So this comes out to be epsilon naught A by 3 by 4 epsilon naught A by D. So now C1 can be written like this, and C2 and C3 can be written like this. So yeah, and it is said one of them is metal. So now either this could be metal or this could be metal. So whenever it is a case of a metal, capacitance will become 0. Correct? Capacitance becomes 0. So if I take, so I'll just put up the values over here. C1 is C by 2. This is 3. Okay, and also dielectric constant K1 will also come in. So this is K1, and here also it will be K2. So into K2 and K3. So here it will be K3. So C1 will be K1 C by 2. C2 will be 3 by 2 K2 C. C3 will, epsilon naught A by D can be written as C. Epsilon naught A by D can be replaced as C. This will be 3 by 4 K3C. Now what we have to do is, now it says in the question, its capacitance changes by, its capacitance changes by 50%. So this goes to show C net. The value of C net will be 3 by 2C. So we can now, we are all set done. Either K1 or K2, one of them is going to be 0. There are two trial and error. By using that method, we have to check it by what value we are getting. This, for example, I'll just show it to you. What we can do is we can check in this question 1 by C2. Let's say if K1 is 0, then 1 plus C2 and 1 plus C3. This will be equal to 1 by C net. Now when you solve this, you get K2 as negative. Correct. When you solve this, you get K2 is negative. That means K1 cannot be 0. Therefore, K1 is not equal to 0. Okay? And when we put this K1C by 2 plus 3 by 4 K3C, this is equal to 3 by 2. So when you solve this whole thing, K3 is given as this 10 by 9. So when you put this, you get answer of K1 as 4 by 3. Answer is 4. I'm not solving this, I've already solved this. So please solve it and see it for yourself. Okay, so now let us see question number 36. So here we are given with potential difference. Let's say V1 is to V2 is 1 is to 2. Area of the plates A1 is to A2 is 1 is to 3. And D1 is to D2 is 1 is to 4. Okay. So the energy stored is half of CV square. So if we find out capacitance is epsilon naught A by D. So C1 is to C2 will be, or if I just put it like this, C1 is to C2 will be A1 D1 into this, which happens to be A1 by A2 into D2 by D1. A1 by A2 is how much? 1 is to 3. And the plates, this is D2 by D1 is 4 by 1, which is 4 by 3. So energy stored is E1 by E2 is C1 by C2 into V1 by V2 happens to be C1 by C2. We have already calculated 4 by 3. V1 by V2 is how much? Potential difference is 1 is to 2. 1 is to 2 ka whole square is 1 by 4, which is 1 by 3. So answer for this is A. So in this question, as we can clearly see, the phase of A and B, this is connected to positive terminal, this is connected to negative terminal. Okay. So what is going to happen is positive charge is going to come over here, over here, over here, and over here. Negative charge is going to come, let's say over here, over here, over here, and over here. So we can see since capacitance of all the, actually if you just connect it, if you just make a circuit diagram, or the three capacitance that are being formed, what are the three capacitance being formed? One is this capacitor. One capacitor is, let's say, yeah, so let's say this is one capacitor, two capacitor, three capacitor, and four capacitor. So here four capacitors are being formed. So now if you make a circuit diagram for this, it will look something like, so if I just number these plates, let's say this is plate 1, 2, 3, 4, and 5. Four capacitors to be formed from these 5 plates. So one, I'll use one twice. Sorry, I'll use, this is plate number 1. This is plate number 2, which is used twice for making 2 capacitors. This is plate number 3, which is used 1 for making 1 capacitor. So this is plate number 4. So plate number 4. This is plate number 5, and this is also plate number 5. Now we see 1 is connected to 2. 2 is connected to 2 because it's the same thing. Similarly, here we get 4 is connected to 4, 5 is connected to 5. 2 is connected to 3. You can see 2 is connected to third plate, 4 is connected to fifth plate, and likewise. And we see this is connected to positive terminal and this connected to negative terminal. So we formed over here 4 capacitances. We get here 4 capacitors basically, each having a capacitance of epsilon naught A by D. So charge on plate 1, it's Q1, is epsilon naught A by D into V, epsilon naught A by D into V, and charge on plate fourth. Which one we are supposed to ask? C, on the plate C. This plate, it's going to be Q2 epsilon naught A by D into V, but we have to see this is actually our C plate. So here also a positive charge and here also. So 2 times this positive charge is occurring. So we have to make it 2 epsilon naught A. This, so option will be D. Moving on to the next question. Question number. So question number 38. 2 point P and Q are just a second. Yeah. So P and Q are 2 points at a distance 3 and 4 meter from a charged sphere. So we all know charged sphere always behaves like a point charge. So distance is 1 meter. So this would be behaving as if charge is kept at a center. Charge Q is kept at the center. Okay, so from here we need to calculate electric field at a distance 3 meters, and from here we need to calculate electric field at a distance 4 meters. So we all know electric field is directly proportional to 1 upon r square, and if we just simply put these values, we get E1 by E2 as, we put 3 and 4, we get 16 is 1 by 3, 1 by 3, so 16 is, yeah, 16 is 2 and 1 by 16 is, repeat this. Moving on to question number 39. So if we see in the process of electric, so what happens in the induction? First we have to know that if let's say a positively charged plate is brought near a conducting material, so negative charge appears here and positive charge appears here. Because charge is appearing from itself, so there is no change in mass. However, if it is if this question would have been little bit different, if we would have earthed this part, so then what would have happened? Then slightly mass would have changed. Okay, so we have to know that. But in this case, it is simply saying process of electric induction, so masses won't change in this case. So in this question, we see the plane, that means if we just consider plane to be like this plane is is placed in an uniform electric field itna 40 newtons per coulomb, plane of the coil making an angle of 30 degree. So if I just take electric field like this and plane like this, so what is the angle that this plane makes with this is 30 degree. This is the plane actually. Okay. And if I draw a perpendicular on this plane, which also happens to be the area vector, this is going to be 60 degree. So now flux we all know is E dot A, which is EA cos 60. Putting all the values over here in SI units, we get answer as D. If we just put the values 40 newtons per coulomb into area as 20 to 10 raised to minus 4 into cos 60 is half, we answer as this. So we all know uh, torque acting due to dipole is what? Torque acting due to dipole is given as PE sine theta, correct? And here we can easily calculate I mean, we need not just put it in a vector format. We can just directly use this relation. P is 1000 into 10 raised to minus 3. P happens to be Q into D. So this is Q and this is D 4 millimeters. Okay, electric field is 20 into 10 raised to 4. And the sine 30, sine 30 is half. So sine 30, we can just write it as half. So this goes with this. And finally, when you solve this whole expression, you get 10, 3, this goes, then 4 into 4 into so I think there's some calculation error going here. So I'll just write down all the values again, rewrite all the values. So P will be 1000 into 10 raised to minus, I think we missed out this term. This is P is Q into D. D is 4 millimeter. 4 into 10 raised to minus 3. E is what? E is 20 into 10 raised to 4. And sine theta is half. So what, when you solve this expression, what this 1000 goes with this, 2 goes with this. So we are left with, here again, we are left with 10 raised to minus 6, 10 raised to 10 raised to 5. So this is 4 into 10 raised to minus 1 Newton meter. This is 0.4 meter. So I guess this is the answer. Moving on to question number 42. So electric dipole of moment P is placed in an uniform electric field E. It aligns itself in a itself with the field. So basically, if P is our dipole moment, if this is, let's say this is the direction of dipole moment, correct? Minus, plus, and if we have electric field, so this will always align in the direction of electric field. This always aligns itself in the direction of electric field. So this is the stable configuration. So if you slightly, slightly, if you, let's say, turn it like this, it will come back again to this, from negative to positive. So now what happens is when you turn this dipole from here to, let's say like this, what happens, it again goes back to this position. So this, in this position, the potential energy of dipole is minus Pe. At this orientation, potential energy is 0, and at this orientation, potential energy is Pe. This is maximum, and this is an unstable state of dipole. Because when you slightly move the dipole like this, it tends to move in the direction of electric field. So this is the unstable state of a dipole. This is the most stable state of a dipole. So it says when you put a dipole like this, let's say, okay, then what will happen? What will be the change in potential energy? Initially we had minus Pe, finally we have Pe. Change in potential energy is Pe minus of minus P, which is 2 Pe, and dipole is unstable. So D is the correct answer. Moving on to the next question, question number 43. So it says a uniformly charged ring. So this is uniformly charged ring, and a Gaussian sphere. Now we have to make a sphere over here. So this is a sphere, This is a ring. Now, this is uniformly charged. Okay, this is uniformly charged. The sphere also obviously, so circles coaxial to it will be equipotential. Why they will be equipotential? Circles which are coaxial to this, they will be equipotential to this. Correct. Reason being very simple. Electric field because of this would be, field lines would be something like this. So this is again a ring. This is again a ring. These both are ring actually. This is a ring. This is also a ring. So both are ring. Now, circles coaxial. So circle coaxial with the ring, they have to be equipotential. We all know. If let's say if this ring is there, field lines are going to look like this. So it's going to be kind of equipotential. However, when we talk about a sphere, so it's something like saying on a sphere, if I keep a charge over here. Okay, if I keep a charge over here, now this charge will obviously will again this will be potent, but when it comes to this surface, it no it's not equipotential at this point. Why? Because when you draw a normal vector over here, it comes out to be like this. Because you have to understand the geometry of a ring and the geometry of a sphere is different. So in case of ring, because we don't have any surface uh, beyond this surface actually. I mean, if you just see the surface part that is contained for a ring is in this region only. Now, if I just go slightly above this, then what would happen to the electric field? Can you imagine what would happen to electric field at this point? Correct. So electric field, that's why won't be always perpendicular to the Gaussian surface, or it won't be always normal to the Gaussian surface. Okay, I hope you got that point. So you have to little bit imagine it over here, because geometry of ring and geometry of sphere is different. Okay, in case I haven't got, I'll just try to explain it once again. So let's say this is a sphere. So if I just make a surface like this, and this is a ring. Now this electric field is not on the, okay. So now let's say this is a coaxial circle on that ring, correct? So obviously electric field goes here and kind of, yeah, now here it's normal, no problem with that. But when we come to this point, let's say when we come to this part of the surface, then what happens? Then if you see, it's going like this. Now it's no longer a normal. You see that? So not always electric field will be perpendicular, normal to the Gaussian surface. So for this, we will have circles coaxial with the ring are equipotentials. Moving on to question number 44. So in this question, on x coordinates, this is x equals to 0. Then we have 1, we have 2, then we have 4, then we have 8, and so on like that. So electric field at this point will be a summation of this, and this. So it's going to be 1 upon 4 pi epsilon naught q naught by q naught by, you know, 1 by r square. And so this is going to be 1 plus 1 square plus 1 plus square plus 1 plus 4 square, so on. Okay, I'm sorry, it is asking potential. So potential is going to be just this. So when you solve this, this is basically in GP. whose sum is a upon 1 minus r. So here a is 1, r is 1 minus 1 by 2. So when you solve the CP, you get it as 2. And so this is potential. I'm sorry, it's not electric field, it's a potential. So V is equal to 2 q naught upon 4 pi epsilon naught. Yeah. So 2 q naught 4 pi epsilon naught. And 45th is a very simple, it's actually just the statement of Gauss law. Q is kept at the center of sphere of radius r. The total flux is going to be Q by epsilon naught. That's just a statement of Gauss law. So Q by epsilon naught. Moving on to integer type questions. So moving on to question number 46. As we can see, this is 25 volts. So actually, since capacitors here are of same values, so what will happen is this 75 volt is will be along the, across this is 75 volts. So across this also will be 75 volts, correct? And since capacitors, as I said, are of same values, so potential across this will be 75 by 3. This will also be 75 by 3, and across this will also be 75 by 3. So we know VA minus VC is going to be VA minus VB plus VB minus VC, which happens to be 75 by 3 plus 75 by 3. V at a point, because you can see this point is earth. So this point will have a potential of 0 and this point will have potential of 75. So VA is 0. I'm sorry, VA is 75 and we just need to calculate VC. Now when you solve this whole thing, you get 75 minus 2 into 75 by 3 equals to VC. From this expression, we get VC as 25. So that is our answer. So for this, integer answer will be 25. Moving on to the next question. Moving on to question number 47. It is said two charges 10 microcoulombs and 20 microcoulombs are at a separation of 2 centimeter. Electric potential at the middle point of the line joining the two charges is. So we need to calculate electric potential at this point. This is 1 centimeter and this is also 1 centimeter. So let's say V due to, we'll assume this is Q1, this is Q2. V1 due to charge Q1 is KQ1 by R. V2 is KQ2 by R. So now, so V1 due to this Q1 is how much? K into Q is 10 into 10 raised to minus 6 upon R is 1 centimeter. 1 centimeter is 10 raised to minus 2. And V2 is K into 20 into 10 raised to minus 6 upon 10 raised to minus 2. So V net over here will be V1 plus V2, which is going to be 9 into 10 raised to 9, 10 into 10 raised to minus 6 plus 20 into 10 raised to minus 6 upon 10 raised to minus 2. So when you solve this expression, what do you get? Let's see. Here it is asked answer in megavolts. So let's see when you solve this, what do you get? So you get 9 into 3, that is 30, into 10 raised to minus 6 into 10 raised to 9 into 10 raised to 2. So this is going to be 270 into 11 minus 6 is 10 raised to 5, or 27 into 10 raised to 6 volts. Now, since answer is asked in megavolts, so it will be 27 megavolts. So that is our final answer. Moving on to question number 48. So if I take these two capacitors, and if I take, okay, so I'll just go step by step from P. So because they are in parallel, so they will add. So this will be 8 microfarad, and here we have 16 microfarad, and then this is 24 and 12. So 24 and 12 will make it 1 by 24 plus 1 by 12 is 1 by C net. So 2, 12 into 2, this is 3 by 24 equals 1 by C net. So this also comes out to be 8 microfarads. So you can see 3, 8. So C net is 8 microfarad. So this also comes out to be 8 microfarad. So 8 plus 8 again comes out to be 16. And then this is going to be 2 microfarad. This is okay, this is some capacitance over here. So 8 and 16, again how much? 1 by 8 plus 1 by 16 equals 1 by C net. So this is 3 by 16 equals 1 by C net. So C net is 16 by 3 microfarad. So this is 16 by 3. And when you solve this, this is 16 by 3. And with this in series will be 1 by 16 plus 1 by 2 equals 1 by C net. This happens to be 8, 8, 9 by 16, 1 by C net. So 16 by 9. Correct? 16 by 9. So now when you, since it's given equivalent is 4. Equivalent, we just need to calculate equivalent, which is 4. So 16 by 3 and 16 by 9 is how much? 16 by 3 plus 16 by 9 is how much? Into 3. This is 4 into 16 by 9 is C net. I'm sorry, it's not C net, it's just, that is some C dash. So if I further break this circuit, this comes out to be like this. So this whole thing is going to be, how much? 16 by 4 into 16 by 9. 4 into 16 by 9. And then we have this capacitor of capacitance C. So 1 by 4 into 16 by 9 plus 1 by C equals to 1 by C net, which is equal to 4. So 1 by C is equal to 1 by 4 minus 9 by 4 into 16. And when you solve this, you get 4 into 16. 4 into 16. I'm sorry. This is just 16 over here. So, I mean, you can just take 1 by 4 is 16 minus 9 into 4 into, you can just write it like this. This becomes 7 into 4 into 16. When you solve this, you get, see, into 16 into 4. 16 into 4 by 7, which happens to be 64 by 7, which is 9.14. Okay, that's the whole solution for this. So in this question, we're given a metal sphere of radius 20 centimeter and the charge which is distributed. Obviously, it has to be distributed over it. It can't be inside it, correct? Uniformly over it, surface. The electric field just outside. So just outside electric field is given as this. Okay, so for a for a sphere, just outside electric field is given by 1 upon 4 pi epsilon naught q by r square. Now, when you put all the values, I think everything is given over here. So just put all the values over here. You get 9 into 10 raised to 9. Q is 4 into 10 raised to minus 9 upon radius is 0.2 whole square. This is E. So when you solve this, you get 9 into 4 into, okay, so I think this and this will go off into 1 by 0.2 whole square. So 0.2 into 0.2 will make it 100. This is 4. That is 900 newtons per coulomb. So because we have to write it in x into 100 format, so it will be 9. 9 will be the answer over here. Last question. So 3 positive charges, each of 1 microcoulombs, placed on the vertices of a triangle. So the potential energy of the system is, so we have to see one pair is this, another pair is this, and another pair could be this. So just simply we need to calculate electrostatic potential energy. So electrostatic potential energy is going to be 1 upon 4 pi epsilon naught Q1 Q2 upon R plus Q2 Q3 upon R plus Q3 Q1 upon R. Okay, so this is 1 upon 4 pi epsilon naught Q square by R into 3. When I just put all the values over here, so I get 1 upon 9 into 10 raised to 9. Q is same, so that is 10 raised to minus 6 whole square upon R. So radius, so the distance is 1 meter, so 1 meter 1 square into 3. So this goes to be 9 into 10 raised to 9, 10 raised to minus 12 into 3. So this is 27 into 10 raised to minus 3 joules, because we want to answer in millijoules. So it will be 27. So 27 will be the answer for this. So with this, we end the discussion of FLT paper 3. Thank you so much.